continuation of example 6.4. Here, from the root locus plot, determining the value of k such that the resulting system has a settling time of 4 seconds. What are the corresponding values of the roots? So that we need to find it. Now, here, before we are going to find that, we calculated that centroid at plus 2, and from the centroid, centroid is the point through which the centroid, the point at which the asymptote passing through, but here the angle of asymptote, we got it as 180 degree. Angle of 180 degree means starting from here 180 degree. So that means it is on the real axis. Okay, starting from here to 180 degree. 180 degree means from here it starts positively. 180 degree means it will come to till here. That means it is on the asymptotes on the real axis. Okay, that is the one thing you should remember it. Other thing, previously last class we studied, we studied here about the stability and the xi. Okay, so this figure is very important. Now here, as you can see here, see, xi omega n, that is actually the real part of a complex conjugate poles. This is the complex conjugate poles. It is the real part of, or yeah, xi omega n is the real part. It is, xi omega n is measured in the negative sigma axis. Okay, so that you should remember it. Okay. Now, when you are coming, and one more thing, we found the previous video that the radius is it is this shows that loci of a complex roots are part of a circle, and the center is at -1, 0, and radius of -2. So here you can see that the center is at -1, 0. That means it is the location of 0 only. From that, the radius is 1 point square root 2. That is means 1.414. So 1.414. So when you are drawing like that, this radius is having this circle is having a radius of 1.44. The radius is given as root 2. So you know that till here to here it is 1. Towards the right side you will get a 0.414. So you can see the radius is 0.414. The other thing regarding it, we already found the root locus strikes on imaginary axis at k is equal to 1 and omega is equal to 1, that we already studied. Now the break point also we found it, 2 break points. One is at s is equal to 0.414. Here also s is equal to minus 2.414, and the corresponding k, the corresponding k, yes, you will get it. only we found the breakaway point and break-in point. Okay, now here, as you can see here, to determine the value of k such that the resulting system has a settling time of 4 seconds. That is last part of your question. First, locate the point on negative real axis, which gives the real part psi omega n. I already shown that psi omega n is the real part of a complex root of the complex pole. Yeah, it is a real part of the complex pole, which is resulting settling time of 4 seconds. So settling time is equal to 4 divided by psi omega n. Psi omega n is equal to 4 by ts. Given settling time is 4 seconds, so 4 by 4 you are getting 1 seconds. So with the real part with the real part that is equal to minus psi omega n. So when you are having real part from here, psi omega n, you got it as minus 1. Yeah, 1. Then you can see here, from here, these are the two poles, or two, yeah, S1, S2. Yeah, what in the question what they asked this, from the roots plot, determining the value of k such that resultant system has a settling time of 4 seconds. What is the corresponding values of the roots? What is the corresponding values of roots? So you have to find the corresponding roots. So now you got that this distance is for settling time psi omega n is equal to 1, means that from 0 you have to go for 1 towards the left. That means you will reach minus 1. Now you have to extend to positive side and negative side. So you know that the radius of this circle is 1.414. So so this point you will get it as S1 is equal to real part is minus 1, imaginary part is equal to the root. Yeah, it is the radius of the circle, that is minus 1 plus j 1.414. Here you are getting S2 is equal to minus 1 minus j 1.414. Now, apart from that, yes, now the values, next we have to find the values of k at s is equal to minus 1 plus j 1.414, or s is equal to minus 1 minus j 1.41. That is for ts equal to, that settling time is 4 seconds, is how you are calculating is as per the rule 9. We study the rule 9. See here, the open loop gain k in pole 0 from at a point S0 on the root locus is given by k product of phasor length from S0 to the open loop poles divided by product of phasor length from S0 to the open loop 0. So it is a phasor length from that point to poles, product of that, divided by product of phasor length from that point to zeros. So now you know that this is your point. From that you need to find the values of k gain. For that, the formula is the phasor length to poles. This is one phasor length and this is another phasor length, 2 poles. You have to find the phasor length to the poles divided by phasor length to the 0. means product of the phasor length to the poles divided by product of the phasor length to the poles. Now, as you can see here, here this distance we already aware that this is the radius, and this distance you know that it is 1. So this distance you can use by using trigonometric formula. That means this is nothing but this, if you are taking y is equal to this is z, this is suppose this is z is 1.44, this a is, this I am taking a, that is equal to 1. So square root of 1.44 square plus 1 square, the square root of that you are getting it as 1.75. So in order to get this distance, that is phasor length to the other pole, it is how you can calculate it. Again, this is a triangle, and this distance can be calculated by this distance square, this distance, the square root of this distance square plus this distance square. So you know, you already aware that trigonometric relationship. Okay, so yeah, so the lengthiest side can, this is a rectangle triangle. So the lengthiest side, the length of the lengthiest side is obtained by square root of other two sides, square root of addition of square of other two sides. So square root of z square plus this distance square. So 1.44 square. So here you know that it is 2. From here to here 1. From here to here 1. So it is 2. So 1 plus 1 2. So square root of 1.44 square plus 2 square. Overall square root, if you are taking, you are getting a distance of this. Now the gain k at this point is nothing but the product of phasor length to the poles divided by product of phasor length to the zeros. So phasor, this we are representing y, this we are representing x. So x into y divided by z. So when you are doing like that, you are getting the gain k is equal to xy is at 2.45 into 1.75 divided by 1.44. It is 2.977. So that is another important point. So here, when you are doing the root locus, you have to study the trigonometric relationship, how to find the angle, how to find the distance of a different side of a triangle. Those things you should be refresh it in order to understand this properly. So after that, you understood that it is a circle and everything is, you aware that. Now yes, so this point, suppose you want to get the gain of this point, what you have to do, you have to find the distance, phasor length to the poles. So from minus, this is minus 2.44, okay, minus 2.44. So distance from here to this pole is 2.414. From here to next to pole is 3.414. So in order to find the gain at this point is this distance 2.414 into 3.414, and you can see that distance to the 0 is 1.414. So divided by 1.44, that is equal to k is equal to 5.83. So everywhere you can find it. So this point we found it. Okay, so here we from the Routh criteria we found these two values. Every point you can calculate it from the poles the root locus starts on a circle, one is going in this direction, one branch going in this directions. This is the breakaway point, this is the break-in point. From here, one will go and terminate it at S0, another will go and terminate at 0 at infinity. So wherever the zeros, k is infinity, wherever poles, where k is equal to 0. So all these points you recollect it. Students, you please study this, try to understand. If you have any doubt, you can ask questions, preferably in a WhatsApp audio through your common WhatsApp group, our classroom WhatsApp group. So please do that. So this will help you. So we will see one more problem. So here, yeah. So draw the complete root locus for g of s into h of s is equal to k divided by s into s plus 2 into s plus 4. And from the root locus plot, find the range of values of k for which the system will have damped oscillatory response. Also determine the value of k for the damping ratio of xi is equal to 0.5. With this value of k, find the closed loop transfer functions. So here, when you are observing it, your transfer function, you can see that there is no zero, there is only poles. All the poles are real, there is no complex. The poles are at s is equal to 0, s is equal to minus 2, s is equal to minus 4. So you can see that there are 3 poles, but there is no distinct zeros. So all the corresponding zeros are at infinity. So n is equal to 3, m is equal to 0, n minus 1 is equal to 3. So you can understand that all the root locus starts from poles and it will end at zeros at infinity. So there are 3 branches, it will go to infinity. And first it is symmetric. First rule, it is symmetric about real axis. The poles, zeros, also symmetric about the real axis. Second part, I told that there are 3 poles and no distinct zeros. So all the root locus start from all the poles and it end at zeros at infinity. So there are 3 branches. Now here, as you can see that, we'll go to the diagram once more. Now you represent the poles. One is at 0, and one is at minus 2, and one is at minus 4. Now you can see that what about this segment? This segment is part of a root locus. You have to check it. How you check it? You have to see that how many number of poles plus zeros right to this. You have to count. So when you are counting this, here one pole and here another pole and here also one pole. So you are considering this segment. Right of this segment, you have to see how many total number of zeros plus poles. So when you are calculating here, there are 3 poles. That means there are odd number. If the number of zeros plus poles to the right in the real axis, if the number of poles and zero is odd number, then this segment is a part of the root locus. Now if you are considering this segment, that means minus 4 to minus 2, if you are checking whether this is part of the root locus, how you will find that? You have to see that how many poles plus zeros to the right hand side. When you are counting, it is 2. Now it is not an odd number, so it is not a part of root locus. Now when you are considering this segment, if you are considering to the right of this, there is one pole, so it is odd number. So this will be a part of root locus. So that is the rule number 3. Okay. Now, so here, in order to find the asymptotes, there are 3 asymptotes, and the angles of the asymptotes are given by, there are 3 asymptotes. The angle of asymptotes are given by, yeah, theta q is equal to 2q plus 1 pi divided by n minus 1. Q start from 0 to n minus m minus 1. n minus 1 is 3, 3 minus 1 is 2. So 0 to 2. When you are substituting q as 0, you are getting pi naught is pi by 3. When you are substituting q as 1, you are getting q1 is 3 pi by 3. 3 pi by 3, that is pi. Theta 2 is 5 pi by, when you are substituting 2, you are getting 5 pi by 3. Now the intersection, the point of intersection of asymptotes on the real axis, that is known as centroid, is given by minus sigma is sum of real parts of poles minus sum of real parts of 0 divided by number of poles minus number of zeros. Sum of real parts, first pole is at 0, the real part is 0. Second pole is minus 2. Third pole is minus 4. Then minus, there is no 0, so 0 divided by n minus m, that is number of poles minus 0, 3 minus 0, so 3. So we are getting it as minus 2. So you will get the centroid. So you have to draw. This is the similar way we did. This will be centroid at minus 2. From that, you have to draw 3 asymptote. One asymptote is 180 degree, like this. One asymptote is, one asymptote is pi by, one asymptote is pi by 3, that means 60. One asymptote is pi by 3, that is 60. Another is 5 pi by 3, 5 pi by 3, that is 300. Yeah, 300. So this is the asymptote, this is another asymptote, and this is that 180 degree asymptotes, and centroid is at minus 2. We identify the segments which are part of the, this one is from here to, and another is this. Okay. Now, yeah, this already we come across. The root locus exists on the real axis from this to this, and left to s is equal to minus 4. Now the breakaway point are given by the solution of equation dk by ds is equal to 0. So g of s into h of s is k divided by s into s plus 2 into s plus 4 is equal to 1. So k is equal to, this will come to the other side, s into s plus 2 into s plus 4. So this is k. So you have to find dk by ds. So when you are doing like that, then you are doing this, if you are expanding it, you are getting it as s raised to 3 plus 6x square plus 8s. So when you are differentiating, you are getting it as 3s square plus 12s plus 8 is equal to 0. So it is again a quadratic equations. So you can see minus b plus or minus square root of b square minus 4ac divided by 2a. So when you are doing like that, you will get minus 12, s is to minus 12 plus or minus square root of b square minus 4ac divided by 6. So when you are getting it, you are getting it as minus 2 plus or minus 1.15. When you are substituting it, you are getting it as the breakaway points is s is equal to minus 3.15 and s is equal to minus 0.85. And here the root locus exists here you can see root locus in the real axis from s is equal to 0 to s is equal to minus 2 and left of minus 4, but here we got 1 as minus 3.15. There is no root locus, so this we cannot consider, but here 0 to minus 2 there is root locus, so s is equal to minus 0.85. That is the point, breakaway point. That is the breakaway point. Yeah, that is the breakaway point. Now, in order to find the angle, breakaway angle, that is plus or minus pi by r, that is plus or minus 180 degree by 2, because there are two branches, that is equal to plus or minus 90 degree. One branch is from minus 4 to infinity. So between two poles there are, so here between these two poles, you can see that between these two poles there is a breakaway with the two branches, so that is why here we took 2. Now there is no need to compute the angle of departure and angle of arrival, as there is no complex poles and zeros. Only that time we need to compute angle of departure and angle of arrival. That already in one problem I saw how we can calculate it. Now the point of intersection of the root locus with the imaginary axis and the marginal value of k can be determined by applying the Routh criterion. So the characteristic equations of this 1 plus g of s into h of s is 1 plus k divided by s plus s into s plus 2 into s plus 4, that is s square plus 6x square plus 8s plus k, that you have to equate to 0. So when you are equating 0, so apply the Routh stability criteria, you are getting this table. Now for the stability, all the element, the first column should be greater than 0. So you will get k should be greater than 0. 48 minus k should be greater than 0. So it indicates that k should be less than 42. Now the marginal value of k for stability is this when you are equating to 0. So k is equal to 48. Now in order to find when this becomes 0, in order to find the points on the imaginary axis, root locus, where it touches or where it cuts the imaginary axis can be found by using the auxiliary equation. This we equated to 0 to find the marginal value of k. So you have to consider the previous terms for the auxiliary equation. So 6x square plus k is equal to 0. In that k value, km is equal to 48. You have to substitute 48. So 6x square plus 48 is equal to s square is equal to minus 8. So s is equal to plus or minus root square 8, that is equal to plus or minus j 2.828. So here you can see that at j 2.828 the root locus cut the imaginary axis or intersect the imaginary axis, and therefore the frequency of sustained oscillations is, now if the points are on the imaginary axis, it is for sustained oscillations. So omega is equal to 2.828 radians per second square. Now the alternate way, you have to substitute s is equal to j omega, then you have to equate the real part and imaginary part. Here j omega cube is there, so it can be that means j omega all raised to cube is j cube omega cube. J cube can be considered as j into j square. J square is minus 1, so minus of j omega cube it will become. Okay, here it is j square omega square, so it is 6 minus 6 omega square. This here 8 j omega plus k. Now what you have to do, you have to equate the real part to 0, there you are getting omega square is equal to 8, omega is root 8. Then you have to equate the imaginary parts. From that you will get k as 48. Now here, in order to find the k at break point, the k at the break point, here this is the break point. Break point we calculate as minus 0.885. So how you can calculate the break point is k at the break point, the formula 9, rule 9, in that you understand that k can be found by the phasor distance from that particular point to all the poles divided by phasor distance to the zeros. So here all you can see that all are poles. So the phasor distance to here is phasor distance is 0.85 to this pole. From this here the k value of this point you need to calculate. So from here to the phasor distance to this pole is 2 minus 0.85, that is 1.15. Okay, and next phasor distance to the fourth pole, that is 4 minus 0.85, that is equal to 3.15. If you are a product of that, when you are calculating, you will get the k value. Now when you are multiplying all this value, you will get the k value of break point. Now the difference between the values of k at the break point and the point of intersection of the root locus with the imaginary axis gives the range of k for which the system has damped oscillatory response. From the graph it is 3.08, k is greater than 3.08 and less than 48. So here when you reach here, it is k is equal to 48. Here it is 3.08. So for damped oscillation conditions, you have to find k greater than 3.08 and k less than 48. So that is explained here. Yeah. Damped oscillatory response. Damped oscillatory response means it is here all. What is damped oscillatory? That diagrams you have to recollect it. That diagrams you have to recollect it. You will see that. Yes, here. So here you see that this is the damped oscillations. That means poles are the poles are complex. Okay, not a real. The poles are complex conjugates. Okay, complex conjugates. Then you are having this damped. Okay, if the poles are on the right, then is over damped. This is under damped. And if the poles are on the imaginary axis, it is oscillatory. Okay, now multiple poles, then it is again the amplitude increasing damping. When here, if the poles are at the center, it is a constant. If the multiple poles on the center, then the amplitude is increasing. So you have to recollect that. Now, if the poles are in this area from here to here, then you can see that it is a damping characteristics. Okay, it is a damping characteristics. This side also it is giving a damping characteristics. Damped oscillatory. Okay. Now find the value of K for xi is equal to 0.5. Now from xi you can find theta is equal to cos inverse of xi, that is cos inverse of 0.5, that is equal to 60 degree. Draw the line, make an angle of theta is 60 degree with respect to the negative real axis. Let the intersect the root locus at A. Since there are so with respect to the negative real axis, so draw the line making an angle of theta is equal to 60 degree with respect to the negative real axis. So with respect to negative real axis, you have to draw an angle of 60 degree. Let it intersect the root locus at A. Since there are no open loop zeros, the product of phasor length drawn from A to all the open loop poles give the value of K at K. Therefore, for K is xi is equal to 0.5 is, so when you are drawing a line like this, it will strike this point and you need to find the phasor length to all the poles. So here also you need to take the trigonometric actions.